In this lesson 6.3, we're going to take a look at medians and altitudes. Median, remember, is kind of in the middle, and we have altitudes, kind of a separate thing, but we're going to look at both. But what a median makes is what's called a centroid. I always think of centroid as kind of sounding space-like. And so a median, when you find the centroid, it is kind of like the center of gravity of a triangle, where you could literally hold up the triangle itself on a pencil from that point and it would balance because it is that, again, center of gravity for the triangle. Medians are the midpoints that connect kind of a vertex to the other side's middle. It is not perpendicular, though, like we saw with our perpendicular bisectors. Those did kind of bisect, but they were perpendicular. These are not perpendicular. So what happens with our centroid is it's kind of got this 2/3, 1/3 relationship. Well, I want you to think more about the segments as double or half, unless you start with the total, and then you would divide it into 3, and that would give you the smaller segment, and then you would just double it to get the bigger one. It's a lot easier than kind of trying to do any fraction work. So for example, if CM is 8, I want you to look at this segment here, HM, which is what 8 is a part of. And so from here to here is 8, and it's the smaller. We can see it's the smaller segment. So if you think about it, would you cut that in half to get this one? No. You'd probably double it because it's longer. So this is 8, we would double it. So again, you're going to either double or cut it in half unless you have the total, which we don't. We only have a part. So I'm going to double it, and then I know that HC or CH is 16. What is HM? Well, the whole thing, now I can add it up. 16 plus 8 is 24. On this next one, I'm given this segment here. Let's see, and we want to kind of put them in here if we can. This one, though, is the total, and so that one kind of gets a little awkward to try and put it in there, but the whole length is 12. So again, when we're given the total, we want to divide by 3 to get the smaller segment. So I'm going to take 12, divide it by 3, and 4 is going to be the smaller segment, PV. So now I know that this one is 4, and so I'm just going to do what? Double it to get this long segment here, which would make that 8. So over here, we've got some more examples. Let's write in what we do know. We know that CG is 6. We know that GF is 2. And we know that FB is 7. So what is GE? GE is the shorter segment when I know the longer one is 6. So instead of doubling, I'm going to cut it in half. So this would be 3 for GE, half of the longer segment that is on that same line. And then if I know that GF is 2, then I can find AG by doubling it, and that would make it 4. And then what is CF over here? Well, it's going to be the same, since it has the same markings, it's on the outside, it's going to be the same as this one, which would be 7. What if it's in a coordinate plane? So here it is graphed. Here are all of our midpoints, and we would just go ahead and connect these to that opposite vertex. But look at that. That is not a pretty point to try and find. And that would take a lot of different crazy stuff. But there is a easier way. And that is with this formula here, where we just add up all the x's and divide by 3, add up all the y's and divide by 3. And that actually will find us our centroid. Now, we want to make sure that we use the vertex points. So these 3 points up here, not our midpoints. So I'm going to go ahead and add 2, 8, and 6, because those are all my x's. And then I'm going to add 3, 5, and 1 for all my y's. And then I'm going to simplify. So this is 16 over 3, and this would be 9 over 3. And I'm going to go ahead and reduce anything that I can reduce. This one is 16 over 3 is really like 5.3. If you want to leave it as a simplified fraction, that's fine too. You can leave it as 5 1/3. And something like that. And then this is 3. So don't leave it as 9 over 3 if you can simplify it to a whole number. So this point right here, yep, 5 and about 1/3 up to 1, 2, 3. Yeah. So that's where my centroid is. Much easier way to find it with that formula. The last part we're going to talk about is altitude. Altitude, I always think of an airplane. So when we measure altitude, we want to measure it from the ground, obviously, and not at a slant. It's going to be from the ground straight up. How high up is that airplane altitude? So it does need to be perpendicular to kind of that bottom or base. And so altitude form the orthocenter. And so here's our orthocenter, and we are just going straight perpendicular. We are not bisecting, we're just perpendicular. And so on this one, we're just going to graph it. We're not going to actually find it because, again, there's really not an easy way to find it. So we're just going to practice graphing it. So what we need to do is we need to find the slope of these sides so that we can then find the perpendicular slope and graph that and kind of see kind of where they intersect. So what is the slope of JH? So I'm just going to count. Remember, slope is rise over run. And so I'm just going to count up and over. Up 1, over 1, 2, 3, 4, 5, 6. So it's kind of like when we did our legs. 1 over 6, though. We're not going to actually do any of our squaring or finding any distance. Just slope. Rise over run. How much did it go up? How much did it go over? From J to I, I'm going down. So that's negative 1, 2, 3, 4 over 2. Well, negative 4 over 2 is the same thing as negative 2 over 1. So we're going to reduce that if possible. And IH, rise over run. So we're going up, and technically you could go this way if you wanted to. But we want our rise on the top. So we're going 1, 2, 3, 4, 5 as a rise, running 4. So what would be perpendicular? Well, all we have to do is change our slopes by flipping them and then changing the sign. Flipping them, changing the sign. Flipping them, changing the sign. If you remember how we did that with in Module 3. So we just flip it and change its sign, opposite reciprocal. So what we're going to do now is we're going to graph these three basically slopes. We're going to go from I, we go from the opposite vertex. So this line right here is opposite of I. So we're going to go from I, and we're going to go, instead of down 6 over 1, I'm going to go up 6, left 1. As long as one of them's negative, we're good. So up 1, 2, 3, 4, 5, 6 over 1. Because I can't really go down 6, so. And then we're going to use a straight edge, unlike what I just did, and draw our line. Now we're going to go from H, and we're going to go up 1 over 2, up 1 over 2. You could also go and make them both negative, because negative over negative is a positive, so you could go down 1 over 2 if you wanted to, and go that direction, but you can also go up 1 over 2. All right, and then we're going to draw our line there. And then from J, last one, we're going to go down 4, 1, 2, 3, 4 over 5 and connect. So right here is our orthocenter. And yeah, finding that point would not be a pretty point. And we could put our little perpendicular symbols in there. And then there is kind of just a summary of all of the 4 types we've seen thus far. And then one for you to fill out kind of on the next page to help you keep things organized, which we can do together.